Okay, so in the last video, we were talking about the 595 shift register, and I showed how that all worked. And basically, the idea with it is just that you can shift in ones and zeros in and out of it, and every time that you hit the clock pulse, then it will shift those guys over. And I talked about this QH prime chip. So once this all gets filled up, or I guess with zeros, or almost, except for this last one, this one's gonna just get pushed out and maybe disappear forever. But it doesn't exactly, because, like we said before, these ones and zeros are gonna get shifted in from right to left, and when it gets to this position, it would normally just disappear from the display, because the display only has the 8 bits here, but this 9th bit is kind of the carryover or overflow. And instead of just falling off the edge of the world, so to speak, it gets outputted to this QH prime pin. And I said what you could do then is you could put multiple of these 595 shift registers together, and what you would do in that case is you would hook up this QH prime pin to the serial in of your next chip. So instead of, here when we clock this the next time, it just goes away and does fall off the edge of the world. In something like this, where you have more than one of them put together, we can see that that won't exactly happen. So I'll show you that here. And same thing, these are the same exact chips. This build is the same thing as this one, except for the fact that I've got 2 chips living inside there, and I've got a couple additional connections so that they're actually hooked up together. And that's exactly what's happening here. Is my first chip on the blue side here, that QH prime pin is hooked up to the serial input of this other chip over here, which is the red side here. So let's see what happens when we have them hooked up like that. And there's always just some junk that's in the registers to begin with, so we're gonna clear that off first. And the only difference actually is this is my data in, this is my reset pin, and this is my clock. So I flip-flop these two between the last two. So we'll go ahead and clear everything out, and we'll clock in a little bit of data there, a couple ones, and just let those shift along here, and let's see what happens when it gets to the point where this would start to fall off the edge. Instead of falling off the edge, it ends up being the first inputs on this other side here. Now the fun thing is I also then took the QH prime pin from my red side here and also hooked that up to the serial input on my blue chip. So if I keep pushing this along, oops, well, I cleared it out here. Let's try that again. You see it jump over to the next side, and when it gets to the end here, it starts all over again. So you can just have that keep going. You don't have to do it this way. You could have it where once it gets to the end here, we could just not hook that QH prime pin up to anything, and it would just fall off. But that's pretty cool. And again, this can be used for lots of stuff. Pretty much the world's your oyster. Anything you can think of to do that would, take advantage of this sort of behavior, you can just go ahead and do it. One thing that's worth noting here is I'm just using one clock button, but that clock is tied to both chips, both their shift register clocks and their register clocks. So all the clocks for all of this stuff is just tied to just this one button. I could change that behavior if I wanted to. I could clock all, 1, 2 clocks on there and 1, 2 clocks on there. I could have up to 4 different buttons to control all this stuff if I really wanted to, but that doesn't really seem necessary for this example. So this just goes to show you that you really can hook a couple or really infinitely many of these ships together as you want to just keep shifting along and shifting along. So that's it for this one.